So first of all, I find this become a habit whenever I speak nowadays and use this slides thing. I apologize for it at the beginning because it works beautifully on my laptop, but then you put it on a projector and you can't really read it from the back. But I'm also, I mean, like anything, if you can't read it, shout, but also I'm like going through it all fairly clearly anyway. It takes ages to make these things with Figlet and then escape them in Markdown so that they work. I always spend like a few weeks when I have a talk to doing that, and then like finish the talk in the last minute. Anyway, so yes, my name's Luke. I'm going to talk about Kubernetes operators. Be largely focusing around the CoreOS operator as a sort of example. Sorry, the Ftd operator by CoreOS as an example, because basically I set out to kind of learn how they work by studying that one, I guess, and this talk kind of came out of that. Okay, so who am I? Background as a developer, more recently, since containers came along, been more and more into that, and drawn to containers and Docker and Kubernetes and that sort of thing. The role I'm in now is my first sort of straight up DevOps role. So pretty new to it, but I've always been like going further and further down the stack, I guess. As Matt said, I'm working for the UK Home Office at the moment. Been there since, I don't know, it's like 9 months or something like that. Recently moved to Croydon last week, which was a bit disappointing. Nothing against Croydon, it's just added about an hour to my commute, but that's fine. So like if I have like what I think is maybe like a special skill, I think, or what I like to do anyway, is taking things that aren't explained well and are really jargony and technical, and just explaining them in normal words, which is basically what this talk is for Kubernetes operators. Because when I first came across them, I was a bit baffled, and I'll go through that sort of journey, I guess, as to what exactly they were. I had the gist of it, of course, but so I think it's actually fairly simple, but it's not that simple when people like Brandon Phillips, who are like on another level, are talking about it, and it's just like, what? It's too technical. Okay, so and yeah, as someone who's background a developer and more and more containers and DevOpsy stuff these days, operators for me kind of like an intersection between the two, so I'm quite excited about them. Yes, I do homebrewing. If you want to know about that, I can talk about that too. Okay, so actually, just to get a gauge of the audience, like, is there any developers here? Okay, anyone who would say they're more like ops? And okay, and cool. Yeah. That's one hand. The other hand, both hands. Yeah. Okay, so it's not that technical to talk, but depending whether you're one side or the other, it may be more or less advanced, but it's not particularly advanced. So there is a bit of code in there, but it's mostly just showing how some things are implemented just to get your head around the idea. I don't think it's particularly deep dive talk. If you're someone who's writing operators every day, you'd be like, yeah, this is obvious. Okay, so did I cover? Yeah, so if this talk's for you. If you're curious about what operators are exactly, you probably have some sort of idea of the gist of it, but actually, what is it? I'm realizing now, I think you've seen this before, haven't you, Ian? Sorry about that. Oh, you haven't? No, you saw the other one. Yeah. Okay, cool. So, and anyone who's interested in automating things on top of Kubernetes, so we're coding against Kubernetes API, that sort of stuff. If you're interested in stateful services on Kubernetes, I think operators are an interesting subject. So if that's an area you're sort of considering, then you might get something out of this. So I hope you'll get something out of this. As I said, it's kind of introductory. So sort of taking back to where I first learned about operators, and I found it a bit hard to get my head around, as I said before. Then I spent some time getting my head around it, and I thought someone else will have the same experience as I have, so I kind of wrote it up, and that's sort of where that was the genesis of this talk, basically. So, so maybe like me, you read the CoreOS Ftd Operators announcement, which I think was November or something late last year sometime. And you're like, cool, this sounds exciting, but what is it exactly? I'm not sure. Maybe you've seen Brandon Phillips do some talks on the subject. I recall he did a podcast on the Cloudcast, which was titled Understanding Kubernetes Operators. And I listened to it, and it was all about like running Kubernetes on Kubernetes. And I was like, well, but what's I didn't understand Kubernetes operators after that thing. So I think maybe I can give it on another level than Brandon can in his genius. Brandon's CTO of CoreOS, for those who don't know. So yes, maybe you were scratching your head a little after this, and that's kind of what I'm here to talk about. So there are some things about operators that are kind of obvious. Obviously, we're talking about things on Kubernetes. And some things I say in the things on Kubernetes, automating things on Kubernetes. One of the things it says in the blog post is that operators encapsulate operational knowledge in code. So like you have, let's say you're an ops person or a sysadmin or something like this, and you're the person who knows how to do a database migration or how to fail over things or back stuff up. Things that are in your head, they may be written down somewhere poorly, but if you're not there that day, like it's going to be bad, right? That stuff that's in your head. So operators supposedly encapsulate that operational knowledge in code. And they leverage the Kubernetes API and primitives in order to do this. So I kind of got that much when I read these things, but I still wasn't quite sure about a few things. So I was thinking, well, Kubernetes, doesn't it already magically do things for you? We've seen those demos by like Kelsey Hightower and others where you have a cluster with services running on it, and you kill some nodes, kill some pods. It's just magical. It restarts them like life's going to be perfect from here on as an ops person since Kubernetes, right? So why do we need anything more, right? I was just thinking, well, I'm somewhat leading the audience, of course, but I'm still not quite sure where it fitted in with all the stuff that Kubernetes does for you. And doesn't it already have primitives such as stateful sets and replica sets to keep the number of instances of things you have running and also to handle connecting to volumes on disk? Because Kubernetes operators are all about stateful services, more or less. So like Kubernetes already has these things. What is operators on top of this? And also I wasn't sure how they're actually built. Like is it a library? Is it just a pattern? Is it an API? I don't know what. Like it's just sounds cool, but what is it? So that's what I set out to sort of talk about. So I kind of want to answer these questions in this previous slide, and I want to explain the relationship between the primitives that Kubernetes has, like the resources, like stateful sets and replica sets and these kind of things, where they overlap and where they don't with operators, and which is basically where they're not enough and what you need in addition to that. And we'll look at the CoreOS Ftd Operator as an example and a reference point, and also some guidelines that CoreOS published back in the early days, well, the early days, 6 months ago, early days of operators, when they announced it, and then they said, here are some guidelines of what, we're declaring the operator pattern, and here are some guidelines to how to sort of follow it. And I'll show some code along the way. And depending on how much time I have, I didn't know what time it was when I started, then I have a few other things. OK, so what's the niche for operators? So we have the concept of a 12-factor app, which has been around a little while now, so much so that many developers today don't really know what it is because they're just natively speaking like this, really. They maybe write apps that are operator in the person sense, friendly, because they're stateless, right? So a 12-factor app is a stateless application which also follows certain other patterns that make it easy to operate, such as using environment variables rather than config files, and not sort of writing things on disk, depending on speaking to other components via APIs, so that basically when your service needs to move from one host to the other, it's easy to do. So if you have 12-factor apps then Kubernetes, and you're running them on Kubernetes, then it will automatically do a bunch of things for you. It'll keep it running when it crashes, or no, it'll restart it when it crashes. And it'll handle node failures by reshuffling. Like it was running on one node, it'll move it to another node when that node goes down. You can also very easily scale it. You say I had 3 instances, now I want 5, and it'll just make it so. And it'll internally load balance traffic using services, a Kubernetes resource. So you don't have to worry about one API speaking to another. There are 5 instances of that other one. Do I need to know about that? No. You just talk to it by name, and it'll load balance for you. So these things Kubernetes does for you when you have a 12-factor application. And this is basically because stateless apps can be destroyed, moved, and upgraded easily because of the fact that they're stateless. So this is basically 12-factor stuff, or at least the relevant parts of the 12-factor concepts. So Kubernetes does all this for you, but if you have a bit of a different kind of application, maybe something like a clustered database, let's use, say, Cassandra as an example. You can't simply reschedule it on any host like a stateless service. At least it's not quite as simple as that. You can, of course, move it. But so let's say you have a Cassandra database on, like, you have 3 instances of it across a cluster, and Kubernetes treats it like a state. If it were treating it like any other app, the node goes down, it'll run it on another node, but then that Cassandra instance will come up, look at its disk, and be like, oh, I've got no data. Maybe on the master, who knows what it thinks, because it's lost its data on disk, right? So moving database instances between nodes with containers is like a bit more complex. You need to do more things, just as you would if you were moving it manually before containers, right? Or before Kubernetes, you have to, like, move the data as well, make it know which one it's on there. Maybe you need to tell its IP address. Who knows? All the databases are different, and we're also not only moving the service and the data, you may also need to do certain operations. So let's say you're scaling a Cassandra cluster. You may take it from 3 nodes to 5 nodes. You might want to run an operation on it, like, I forget what it's called. Like, you want to rebalance the keys in some way so that they're not sort of clustered on these 3 nodes. They're evenly distributed across 5. What I'm sort of getting at is not these implementation details in particular, but different databases are different. They require special treatment, and that operational knowledge is kind of becomes important when thinking about what operators are. They're not like stateful apps. They're not like stateless apps. Specialist knowledge, yes. OK, so it's this gap is what makes, if that's the kind of niche for operators. So it's about what Kubernetes will do for you and what it won't do for you, and probably never should, really. So they fill the gap of that those application-specific things that Kubernetes won't do for you, largely around stateful services. And Kubernetes operators leverage existing components and resources within Kubernetes in order to do that. And they extend the API, and they're sort of, what's automation on top of Kubernetes in order to handle stateful services. And there's a quote here from the announcement blog post. An operator represents human operational knowledge in software to reliably manage an application. And also with this, complex manual operational tasks become a single command. So, like, if you've used Kubernetes, you may recall that moment where you say kube control scale replicas equals 5 or whatever, and you just get 2 more things, right? What's happening there used to take you a lot more work, right? Let's imagine before containers, we were back in, like, VMs or something like this, right? You might have to spin up a new host. It's a bit of a facetious example, of course, but you might have to spin up a new host. You might have to put code on there, like just configure the host. Then you need to run the service on there with certain configuration, hook it up to talk to the other things. Kubernetes does all this for you, and that's still quite complex, but it's doing it and giving you a one-line interface to doing that kind of task, right? So when we have operators, it's another higher level thing. We could then have an operator that does a whole bunch more things, such as moving stateful data, for a stateful application, but still maybe give you an interface that's a one line, like scale my database, right? So it's another higher level thing. It's automating a bunch of things that were once quite manual. Okay, so forgive me for reading here, but a few things from the blog post, which I think explain it quite well. It was November, yeah, good. So a site reliability engineer is a person that operates an application. A different resolution here to here. Operates an application by writing software. They're an engineer, developer who knows how to develop software specifically for a particular application domain. The resulting piece of software has an application's operational domain knowledge programmed into it. We call this new class of software operators. An operator is an application-specific controller that extends the Kubernetes API to create, configure, and manage instances of complex stateful applications on behalf of a Kubernetes user. It builds upon the basic Kubernetes resource and controller concepts, but includes domain or application-specific knowledge to automate common tasks. Sorry, the last one I'm going to read out. An operator is software that encodes this domain knowledge and extends the Kubernetes API through the third-party resources mechanism, which we'll talk about in a moment, enabling users to create, configure, and manage applications. What they're talking about here is you declare basically a type for your thing that you're operating. Say you might declare Cassandra cluster, right? You declare this as a type, and then you can execute commands on it just as you can now with built-in Kubernetes resources, like scale pods. You might say scale, well, it's not cool. You end up being able to speak about it as though it was a Kubernetes native resource. Like Kubernetes built-in resources, an operator doesn't manage a single instance of an application, but multiple instances across the cluster. So you're declaring a type Cassandra cluster rather than Cassandra instance, if that makes sense. I don't know why I'm using Cassandra as an example, but it could be anything. OK, so the Ftd operator was the first one announced by CoreOS when they published this blog post that I've been quoting from, declaring sort of the concept of operators, and also here's their first one, the Ftd operator. So for those who don't know, Ftd is a key value store, strongly consistent. It's a database for our purposes here. And it's kind of like Zookeeper, maybe if you're familiar with that. And it's a core component of Kubernetes. OK, so they envisage more. I first wrote these slides a while back, so this one's a bit out of date. They envisaged, at the time, more operators being written. Since then, they've published one for Prometheus, and I think for Elastic, and for Rook, I think. Right. So I think that's all. Maybe there's another one. But they said when they announced the first one that they envisaged them being written for things like Postgres and Cassandra and that kind of thing. But I'll focus on the Ftd one just because it's all the same concept, really. So the Ftd operator has, and I should mention also that this is November, and CoreOS are announcing this new thing called operators. But as we'll see as we go along, operators are just a pattern for automating stuff on Kubernetes, and they're not the first or the last people to do that. But they've declared this concept of operators. There are other people out there who are writing operators, whether they call them operators or not. Stat, for example, doing a lot of stuff around stateful services on Kubernetes, so also writing operators. But this was kind of what they wanted to do, was set out a kind of a standard pattern that everyone could kind of follow and sort of work out the best way to do this using a pattern that everyone could sort of share, I guess, which I think is important. So the Ftd operator has the following features. It can create and destroy an Ftd cluster. It can resize it, back up and upgrade, and which are quite significant tasks, really. Like when Ftd first came out, it's version 3 point something now. It's really very solid and much easier to handle operationally. But when it first came out, it was a really sensitive thing. You could lose quorum quite easily, and then getting it back was a nightmare. And just having it move around and stuff like that, it was hard to manage. Like I say, now it's much better, but an operator doing it for you would just be a dream, because you just don't have to deal with any of that stuff. The idea of resizing something like an Ftd cluster is not a trivial thing, so they're quite significant list of features, basically. The operators follow the Ftd operator, and more generally, CoreOS's idea of operator pattern, follow the model observe, analyze, and act. That link goes to a picture. I'll publish these slides later, by the way, on Twitter, but I haven't got the... Oh, wait, I'll just get it up. I think that's the one. Cool. Right. Nice. Observe, analyze, act. There's another. No, that's the one. So basically, observe step is grab the state of the cluster, and then analyze. Look at that state and look at the state that you've sort of declared you want to have. So, and then decide what to do about it, and then act. So as an example here, it's like cluster A has 2 running pods, one on one version and one on another version of Etcd, that is. Analyze, it's identified that the cluster should have 3 members, first of all, so it needs to add a new one. And they should be on version 3.1.0. So what it decides to do in the act is recover 1 member, because it's down to 2. There's probably one there that's lost or stopped or something like that. Recover that, find its data, keep it on the same host, keep it together, and back up the cluster, and then upgrade to the new version. So it's kind of like that declarative configuration model that we see so much in Kubernetes, where you don't say increase the cluster size by 1. You say, I want the cluster to have this size, and it will work towards it. It's a declarative model of configuration, and Kubernetes operators follow that same sort of declarative configuration model. So yes, observe, analyze, act. And we'll look at some examples of this. In this blog post, which is the same one, in this part of the blog post, I always forget which page I'm on, they have this, did that actually zoom or just say it was? It'll probably happen later. Right, so they have this, how can you create an operator? And there are 7 steps. So they're basically publishing a guidelines of how they think this operator pattern should work. So we'll go through that one at a time. So I think something I forgot to mention earlier, I'm referring to the operator pattern, whereas earlier I was saying, is it a pattern, is it a library, what have you, but I didn't really specifically address that. It is just a pattern. CoreOS, the Kubernetes operators are not like a library you download for Golang and implement or something like that. It's just a guideline for a pattern we can follow in automating stuff on Kubernetes. So, which is one of the difficulties I had in getting my head around. I was like, what is it exactly? It's just some guidelines. There's nothing more. So we'll go through some of those. The first one, like I said, there were 7 on that previous screen. The first one is operators should install as a single deployment. For example, kubectl create, and you give it a YAML file of the deployment and take no additional action once installed. So I have an example of an operator which I've basically forked from Kubernetes examples. And don't worry, I'll make it bigger. Give me a second. Okay, so this. So this is an example of, it says Postgres operator, like I just called the project that. It's not a Postgres operator yet. But this is an example of what it would look like if you were following this instruction, right? So you need to be able to create an operator with just a kubectl create, give it a YAML file, and that would be something like this. For those familiar with Kubernetes, you'll recognize this. It is something very simple. It's just saying it's one replica with one container, and it's like in the etcd example, this would be CoreOS, etcd operator, version, what have you. It's just running a container, which is your operator code, maybe having some config, but it's very simple. All this is doing is just saying, run one container for me, please. And like it says, take no additional action once installed. So that's that. Then it's kind of disingenuous to say no additional action, because this one says operators should create a new third-party resource type when installed into Kubernetes, and a user will create new application instances using this type. So what this means is that when the operator starts, the first thing it should do is register a new third-party resource for the thing that it's operating. So the etcd operator will register etcd cluster, or our Postgres one might register Postgres cluster, that kind of thing. And then it will just kind of wait. That's all it will do when you launch the operator. What it means to have registered a third-party resource is that you can then talk to Kubernetes about that resource and say, do like create, or you can say create and delete this kind of resource. So I'll show an example of this. First of all, I'll show you what it looks like to register a third-party resource. Like I said, this is obviously not a coding talk, but just to show you that it's really not that complicated, basically. So I've got this code, which, as I said, as you can see from the copyright, it's from the Kubernetes examples. It's under third-party resource examples. It's quite a good example. So I'll just jump to the bit where this actually happens. It's slightly difficult to work on this screen because I'm not seeing the same thing that you're seeing. OK, so we want, bear with me. OK, create TPR. So this is the main function. All it's doing is handling like command line arguments. Then it's saying create a third-party resource. Then it goes off my screen, which is kind of difficult. And then it sort of creates a client to talk to that that cluster. Creates a controller, which is a long-running thing that will do the polling and watching of etcd, and then it just kind of waits. That's what it really does. But I'll show you what that looks like, the actual create third-party resource. I can't see the bottom line of my screen. It's really difficult. Yeah, that one. OK, so oh, man. This is much easier when I have looking at the same thing that you're looking at. I think it's this one. OK, sorry, here we go. Create TPR. So when the actual registering with Kubernetes of a third-party resource is only these couple of lines, just from here to here. Basically, declaring an object of type third-party resource, which is using the Kubernetes like Golang library, giving it a name and a version and a description, because we've declared that that's the schema we want. And then you just say third-party resource.create. That makes a call to Kubernetes API and makes it. So my aim in showing you these things is just to kind of demystify when you read these guidelines, you say, what does that actually mean? It's nothing. It's just making an API call, creating a third-party resource. How am I doing for time? OK. So it's that simple. Operators, number 3 of 7, operators should leverage built-in Kubernetes primitives like services and replica sets when possible to leverage well-tested and well-understood code. The Ftd operator, so they're basically saying don't re-implement the stuff that Kubernetes already gives you, but leverage it when you're extending it. So when I'm looking through the code for Ftd Operator, I noticed that in some cases it does do this, in some cases it doesn't, and I thought that was a bit weird, but it actually made sense. So as an example of where it does do this is the backup feature. When you use the operator to run a backup of etcd, it will launch a backup operator container and use a replica set of size 1, which is just making sure that it stays up. If it crashes, it'll restart it for you. So it's not writing its own code to keep that container running. It's using Kubernetes to do that for it. But there's a case where it doesn't. The actual scaling of an etcd cluster, that's not done in the operator with a replica set. And it's actually got code where it's looking and seeing, OK, there are 2 instances, there should be 3, spinning up another one. And I was thinking that sounds contradictory to this instruction. But the reason for that is because, and this goes back to the heart of what operators are really, is that the built-in features of Kubernetes can't do everything for you. They can't do the application-specific stuff for you. So if the operator leveraged a replica set for etcd, it would mean that it would scale it for you, and you'd have no control over the actions of what to do when you scale it. You can't put in hooks and say, OK, scale it for me, but just before you start it, let me do this, like move the data, for example. You can't do that with that. So it actually has to write that code itself. So there is code in the etcd operator, which is doing that sort of how many nodes should I have, how many do I have, spinning up nodes, reconciling it, and stuff like that. So sometimes it seems to not follow this, but it's for good reason, because that's, so I'm not going to show the code for this because I don't want to go over my time. We've got more points to get through. You can imagine it's fetching the number of nodes, looking at the config, spinning up more nodes. But you can look at the code yourself. It's quite simple. Quite simple at a higher level, but once you get under the hood, it's kind of, it's complex stuff. It's stateful services, right? So item number 4, operators should be backward compatible and always understand previous versions of resources the user has created. This just seems like a good idea, right? Should be backwards compatible. Number 5, operators should be designed so that application instances continue to run unaffected if the operator is stopped or removed. Just just like you want your services to keep running when your sysadmin has the day off, you also want your database to keep running when if your operator crashes, right? It shouldn't depend on it. It shouldn't be like the parent process as an analogy. It should be there to perform operations when you need it to or when it needs to, but otherwise the databases will continue to run. That's kind of obvious, but important. Operators should give users the ability to declare a desired version and orchestrate application upgrades based on the desired version. So we saw this earlier in the, where's my thing? We saw that earlier in this, where I was talking about declarative configuration. You should be able to say, I want this many instances of this version of the cluster, and it should work the cluster towards what you asked for. That's what this one's about. Cool. And the last one, operators should be tested against a Chaos Monkey test suite that simulates potential failures of pods, configuration, and networking. So we've probably all seen places like Netflix and Amazon using Chaos Monkey type techniques to, it's quite exciting, it's quite cool. But for me, it always sounds really, advanced. But when you look at the code for the Ftd operator, there's the functionality that does this is about 100 lines, and all it's doing is sleeping, waking up on a probability, will I kill something and how many will I kill, and then sleeping again. That's all it does. But when you think about, like we've all developed, well, many of us I'm sure have developed distributed systems or at least clustered applications, and you test and you test and you test, but if you think of the value that just that simple test would give you on top of what you're already doing, it's huge for something that's really quite cheap to do. So I'll show you, how am I doing for time? Okay, cool. So I'll just show you briefly that code, just to show you how simple it is. So in the command line arguments, it just basically takes a chaos level, which is like how aggressively will it kill things. Then it launches this thing called start chaos if you're running in that mode, and that is just creating this chaos thing with the configuration that you asked for, right? So now that code is in package chaos. Like I said, that's, you can't see it there, 99 lines. All that's doing is, in a loop, wait for a time, what's my probability for killing a pod, decide how many to kill, go through in a loop, kill, 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 kill. It's that simple, but hugely advantageous to the robustness of your code. Not going to do the demo for time. OK, so just to wind it up, some example use cases of operators is anything that is application-specific, that has application-specific operational and maintenance tasks. So database is the prime candidate for these things, such as any database, basically, but also non-cloud native applications that maybe store things on disk or have any kind of they don't like to be moved around, basically. If there are things that you need to do in order to sort of nurse this service across from one host to another, then maybe an operator would be a good example to do it, but databases are the obvious one. So any apps that don't like to be moved without some manual intervention. So operators are a step towards fully automated infrastructure. By no means do they get us there. Even the Ftd operator, which has been around a little while now, I think it's still in beta, and they are using it, as I understand, for Tectonic, but I still find it slightly disconcerting to have an automated piece of code running my database and just assuming everything's going to be OK. But CoreOS is very good, so I'm sure it's excellent. And self-operating and self-healing systems and infrastructure already exist, but with our kind of trajectory from VMs to containers to Kubernetes and orchestrators and these kind of things, we're now just getting the tools to make this stuff really easy to build, whereas once upon a time it was much more difficult. And the emergence of operators as a pattern is a way to start to define how we might approach this, to build self-managing systems on top of Kubernetes. People are still keeping databases out of Kubernetes. And there's still some apprehension around it, but I think we're running out of excuses because the tools are there for us to be able to do this much better. Just with sufficient testing, we can do quite robust things, again, as guys at JetStack are doing. And I think that is the end.